Hey there, geometry class. In this video, I want to talk about sections 2.5 and 2.6 in your textbook, which deal with algebraic proof and geometric proof. So that's what we're looking at here. Please, if you can, follow along with your book, because I'm going to give you some problems to do out of it. And that way I'll check to see that you've watched the video. And again, pause the video at any time if you need some time to write things down. All right. Here we go. Proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. What this means is we're talking deductive reasoning. When you have an argument with your parents as to why you should stay out later, if you're arguing with your boyfriend about why he was talking to so-and-so, you are using deductive reasoning to prove a point. In math world, a proof is a way to communicate a solution. So on page 104 in your book, you have these properties of equality which you learned in algebra. I want you to get these written down into your notes. I'll come around and check them. So of course, pause the video here and get that. Now, remember, distributive property states that A times a quantity, something in parentheses, you distribute that term A to both B and C. All right, let's try a little example. Check it out, page 104. It says, solve the equation 1/2 t equals -7. Write a justification for each step. Well, you're probably thinking, yeah, Mr. Rising, I got it now. I mean, I can solve that no problem. But the key here, when we talk about proof, is explaining your reason why. So let's walk through it step by step. So step one is, all right, 1/2 t equals -7. Okay, that's kind of the given. That's what you're starting with. So when you do a proof from this day forward, you start with the given information and you're working your way towards a conclusion. In this case, we're talking about to solve something, t equals some value, whether there's a real solution or no solution or whatnot. That's what we're working for. All right, so here it is. We've set up the original equation. That's given. The next step. Well, what do you want to do? Let's multiply both sides by 2. Well, what are we doing when we multiply both sides by 2? Well, that, of course, is the multiplication property of equality. What you need to do in this section is justify each step. All right, after you multiply each side by 2, of course, you simplify, right? And there it is, t equals -14. So like algebra, geometry uses all sorts of things to represent unknown values. So like here, AB, capital A, capital B, represents the length from A to B. I don't know what it is, but I know it's a variable. It's got some kind of value. So you can use the same properties of equality in algebra as you do in geometry. So let's try this. Here's another set of tables from your notes. I do want you to get these in. My phone's ringing. Hang on. Perfect timing of that ring. What I'd like you to do is get these properties of congruence written into your notes. Again, reflexive property of congruence. One thing equals, or I should say, one thing is congruent to itself. So in this diagram here, I've got a triangle AEF, and I have another triangle BEF. Well, they both share this segment EF. And this is really important later on. You're going to use this step a lot, where you're saying one part of one figure is congruent to the same part in another figure, and that's reflexive property of congruence. Symmetric property, angle 1 congruent to 2, 2 congruent to 3. And transitive really is this idea of syllogism. So, if one angle or segment is congruent to another, and that one is congruent to a third, well then of course the first is congruent to the third. So take a moment to get this table into your notes. This is on page, how about 106. Next thing I want to do is go through an example, and this is on page 106 as well, and it talks about writing a justification for each step. So we're doing a proof here, so to speak, and why are we doing the things that we're doing? So the measure of ABC, ABC is the measure of ABD and DBC. Well, what property is that? Well, of course, that's angle addition postulate, right? We're saying, oh, those are the angles, right? The sum of the parts equals the whole. Then we essentially substitute those values, right? And say, oh, well, if this one's 3x and this is 6x minus 16, we can substitute those expressions in for the measures of those angles. Well, then you're looking at this like, oh, what did we do here? We got 3x. Oh, wait, that's simplifying, right? That's combining like terms. That's simplifying. Finally, we have negative x equals negative 11. What did we do? Well, we subtracted 9x from both sides. So that's subtraction property of equality. And finally, how did we get negative x equals negative 11? You could say that's dividing by negative 1 or multiplying by negative 1. And they're saying multiplication property of equality. So again, this idea is we have these steps. This problem is an example of combining geometry and algebra. Example 4 in the book says identify the property. So it just wants you to practice, hey, DE equals GH, so GH equals DE. Of course, that's symmetry. When you see one angle or measure equal to itself, that is reflexive. When you see 0 equals A, so anything dealing with 0, when you get back to that, is really like the identity property or transitive property. And finally here, this transitive property, A equals 0 and A equals X, so you're gonna skip a step. Syllogism, 0 equals X. The last one here, again, angle A is congruent to Y, so Y is congruent to A. That, of course, is symmetry. One being congruent to the other, so the other is congruent to the original. All right, now that you've got all that down and solid, let's get into section 2.6, which is talking about writing proofs. And the key, again, is when you go from hypothesis to conclusion, everything that we can use to justify our steps has to be written out. We're going to use definitions, postulates, properties, and theorems. All right, so we're starting with a hypothesis. We're going to take deductive reasoning. We're going to take these steps, we're going to justify them, and we're going to reach our conclusion. So here we go. Let's try a little matching game. So what I want you to do is match these terms, definition, postulate, property, and theorem, to these 4, call them definitions. And then down here with W, X, Y, and Z, see if you can figure out which one's a definition, which one's a postulate, which one's a property, and which one's a theorem. Go ahead, pause the video and try that now. Oh, very good. All right, you're back. Let's try it. A definition, of course, can be written as a biconditional statement, right? A property is an attribute of a mathematical statement. A postulate is something we accept without proof. And of course, a theorem is anything we can prove. So when I go down here, I could say, oh, vertical angles are congruent. That is a theorem. What did you say? Who was that? Was that Callista, was that you? Okay, you went blue. All right, we'll put in blue. All right, there we go. True, or not true. Vertical angles are congruent. That's a theorem. Through any 2 points, there's exactly one line. Well, that's a postulate. That's one of the postulates that we studied. So let's put that in, right? That is a postulate. A ray is a part of a line that starts in at an endpoint and goes forever. All right. So that is a definition. And of course, that leaves if A equals B, then B equals A. That's symmetry. And we'll put that one in green. That is a property. All right, geometric proof. Again, we're going from hypothesis to conclusion. We have statements on the left and the reasons on the right. So this is a 2-column proof. You're going to start with your given information, and you're going to work your way down to your conclusion. Repeat. Start with your given information and work your way down logically towards your conclusion. So what does it look like? Let's just try this one. Write a justification for each step given that angle A and angle B are supplementary and the measure of angle A equals 45 degrees. Okay, again, on the left, we've got our statements. On the right, we have our reasons. So first, I'll call it opening remarks. Angle A and angle B are supplementary, and the measure of A is 45. Well, that's given. Always start with your given information. You'll see variations of this, but as a general rule, always start with your given information. Step 2, what does that mean that A and B are supplementary? Well, it means that the measure of angle A plus the measure of angle B equals 180 degrees. Well, why do you know that? What's your reason? Of course, that's the definition of supplementary angles. All right, so then we are substituting this little given piece of information here. The measure of angle A is 45 degrees. So that is substitution, right? And what we're doing is we're combining steps 1 and 3. We're taking a given from step 1 and we're substituting here from step number 2. Finally, that means the measure of angle B equals 135 degrees, and that's because of the subtraction property of equality. Let's take a look at the next one here. All right, I'm back after a quick interruption. Write a justification for each step given that B is the midpoint of AC and AB is congruent to EF. Okay, statements and reasons. B is the midpoint of AC. That's given. What does that mean, midpoint of AC? Well, that means AB is congruent to BC. Makes sense. That's the definition of a midpoint. Well, then here, AB congruent to EF. Why did we write that again? Well, we need to establish it somewhere here in our statements. That's another given. And finally, what are we doing? We are substituting, transitive property of congruence, which feels like a substitution, right? If BC is congruent to AB and AB is congruent to EF, then BC is congruent to EF, and that is transitive property. So helpful hints: when you combine steps, you're going to see them indicated by like step 1 and 3. And again, a theorem is any statement that you can prove. Once you have proven a theorem, you can use it as a reason in later proofs. You already have these theorems written down. It is really important that you get them in your notes and you understand why. Congruent supplements and linear pair. If they form a linear pair, then the angles are supplementary. I think the last thing I really want to look at here, we might have a couple more, is fill in the blanks to complete a 2-column proof. So now we're going to go through this process and try to do things together. This is page 111. So it says, given that 1 and 2 are supplementary and 2 and 3 are supplementary, prove that angle 1 is congruent to angle 3. Well, reason 1 given, let's start with what is your given information, right? Angle 1 and 2 are supplementary. The next step, definition of supplementary angles. So we are defining. I should also have angles 2 and 3 are supplementary up here. So now we're saying, hey, by the definition of supplementary angles, they both add up to 180. So what does that mean? Now we're going to substitute 180 for angle 2 and 3. And so it looks like the measure of angle 1 plus the measure of angle 2 equals the measure of 2 plus the measure of 3, right? The measure of angle 2 in one is equal to the measure of angle 2 in the other. That's reflexive. Step 5, the measure of 1 equals the measure of 3. Well, what did we do? That's right, we just subtracted the measure of 2 from both. And finally, D, angle 1 is congruent to angle 3. If you can, start with a plan. It's always good to start with a plan before you move on. And I'll do another example here. If they give you a plan, go ahead and use it. And that's really what I want to conclude with here is when they, in example 3, take a look at this in your book. When they give you a plan, follow it out. So if you look at this in your book, here's the breakdown of that plan. Good job, 15 minutes. Whew, a lot of information here. We'll talk more when we meet next.